today we are going to study the chapter circles. Now this is a very important chapter from the perspective of IIT JEE and also from the perspective of your board exams. Now apart from this, this is a very easy chapter and you can easily get a mastery over this chapter. So on the day of your JEE exam, you will have very easy marks if you have complete practice and hold on this topic. So what is basically a circle? A circle, let us say we fix a point and we fix another point. We don't fix another point basically. We take another point which is at a distance, fixed distance from this fixed point. So let us say here A is our fixed point which has coordinates h, k, and this another point, let's say P, has coordinates x, y, and it is at a distance of r. Now this r is constant, this is fixed. So how you can imagine this is, let us say we have taken a thread which is of the length r, we have fixed one end of the thread at a point A and the other end of the thread is free to move. It can move all around this point A. So what we will get, you can imagine, is nothing but some figure which will be obviously a 2D figure and it will be something of this kind. So this is basically what a circle is. A circle is the locus of a point which is at a fixed distance from a fixed point. Now this fixed point, this is our fixed point, and this is the fixed length of the string which is called the radius. Now in order to find the equation of a circle, so first what we are going to do here is we are trying to represent the circle in a form of an equation. Now coordinate geometry, as we have already discussed, is a mixture of algebra and geometry. What we want to do here is we want to use the techniques of algebra to represent this geometrical shape and then study the technicalities of the circle in terms of algebra. Because what happens is when we draw a circle, we have to figure out, let's say, the length of a tangent or a length of a chord or how far a point is from the center of the circle. We need fixed points, and if you want to do those things, either we can do those by calculations or you would require geometry for finding out the length of the tangents or the length of the chords which is at a particular distance. So but the idea of why we use algebra here is algebra will give us the exact values and it will help us to figure out what those distances and the points are from a particular point. Now here, when we have started circle, we have discussed two things. One is a fixed point which is called as the center, and the fixed distance about this point A where the point rotates is called the radius. Now in order to find the equation of the circle, we have one condition, that is AP is equal to R. Now if we have to find the distance between 2 points A and P which has coordinates h, k and x, y respectively, we know distance formula. So we can straight away write AP is h minus x whole square plus k minus y whole square. This is equal to R. Now if we square this, what we have is, let's write x minus h whole square and y minus k whole square. So this is the equation of a circle which has center at h, k and which has a radius r. So if you put this equal to 0, the term inside the bracket here equal to 0, you will get the x coordinate of the center, and if you put this bracket equal to 0, you will get the y coordinate of the center. And if you take the square root of the constant which is on the right hand side, you will get nothing but the radius. So this is the standard equation of a circle. And this is also known as the central form, because here we are using the center and the radius to find the equation. So another name for this is central form of the equation of a circle. Now that we have seen the equation in the standard form, let us now try to understand some of the special cases. For example, what happens if the center of the circle coincides with the origin? So what will happen to the equation? So let me just begin with writing some special cases. Number 1, when the center of the circle is at 0, 0, which is the origin. So let me just draw a line over here so that yes. So now let me first draw an x-axis. Let me draw another y-axis, and then we have a circle. So this point is the origin, which we represent by O, and we have a circle whose center is at origin. So let me name this x, x dash, y, and y dash. Now if our circle is this, clearly the center, which in the above form was h comma k, in this case is 0 comma 0. And let us take the radius same, which is equal to r. So what equation becomes, that we have x minus 0 whole square plus y minus 0 whole square is equal to r square, and hence we have x square plus y square equal to r square. So this is the case when the center of the circle is at the origin. Let us take another case. Now what happens if the center is not at the origin, but the circle passes through the origin? Let us say the circle passes through origin. In other words, the origin is lying on the circle. So let me draw the circle to begin with. This is our x-axis. This is our y-axis. And say this is the circle which we are talking about. So somewhere here we can consider the center. Let us represent the center by a point C having coordinates h comma k. Now we want to write this equation, so let us mark our axis and the origin. Now in order to find the equation of the circle, we have x minus h whole square plus y minus k whole square equal to r square. Now in order to see what happens here, let me just join the origin and the center, and from center let me draw a line which is perpendicular to the x-axis. We call this point, let us say, M. So the distance OM is nothing but h, and the distance CM is nothing but k, and OC is nothing but r. So clearly, by using Pythagoras theorem, we have h square plus k square is equal to r square. So this is the standard form, and this is another condition which we have figured out in this particular special case. So let's see what happens if we substitute the value of h square plus k square in this equation. So what we have is x square plus h square minus 2hx plus y square plus k square minus 2ky equal to r square. Now since h square plus k square is equal to r square, we can easily get rid of these three constant terms. And now what we are left with is nothing but x square plus y square minus 2hx minus 2ky, and on the right hand side we have nothing but a 0. Now note this equation. Here we do not have a constant term. The idea is fairly simple, because when we substitute x equal to 0 and y equal to 0, all these four terms become 0, and hence there should not be any constant term on the left hand side, otherwise the right hand side will not be 0. And since origin is lying on this circle, this equation should satisfy the points of the origin, which is nothing but 0, 0. Now after having studied two special cases, let me move on to the third case. The third case is when the circle is touching the x-axis. So first let us see how the diagram in this case looks like. Here is our axis of x. Here we have our y-axis, and we have a circle which is just touching the x-axis. Let us say C is the center having coordinates h, k, and this circle has a radius r. So this perpendicular distance is r. Now from the figure you can easily make out that the constant k will be equal to r, which is the y coordinate. Now if we use this value in the standard equation of a circle, let us see what do we have. So we get x minus h whole square plus y minus k whole square equal to r square. On substituting k equal to r, we have x square plus h square minus 2hx plus y square plus, now instead of k we are using r, so we have r square minus 2yr is equal to r square. Now r square and r square gets cancelled, and what we are now left with is x square plus y square minus 2hx minus 2ry plus h square equal to 0. So this is the case when the circle is simply touching the x-axis. moving on, we have the fourth case when the circle is touching the y-axis. So this is our circle. Let us say the center has coordinates h, k, and it has a radius r. So it is touching the y-axis. So in this case, clearly h will be equal to r, and the equation that we had, x minus h whole square plus y minus k whole square equal to r square, will become x square plus, instead of h now we are putting r, we have r square minus 2hr plus y square plus k square minus 2ky equal to r square. So r square again gets cancelled, and what we are left with is x square plus y square minus 2hr minus 2ky plus k square equal to 0. So this is the equation of the circle when the circle is just touching the y-axis. Now let us move on, and so what next question we just come to, or it just comes to our mind, is what happens if the circle we have is touching both the axes. So the next special case is the case where the circle is touching both the axes. So let me just draw the diagram. It will help you to visualize what is actually going on and will help you to have a clearer understanding. So now we have the x and y coordinate, and the circle now is touching both the x-axis and the y-axis. Again, let us say the center is C, H, k, and if the radius is r, this distance and this distance, which is the perpendicular distance from the axis, will also be r. So here we have h equal to r, and k will also be equal to r. So our standard equation becomes x minus r whole square plus y minus r whole square equal to radius square. So we have x square plus r square minus 2rx plus y square plus r square minus 2ry equal to r square. So r square and r square we can cancel out, and what we are left with is x square plus y square minus 2rx minus 2ry plus r square is equal to 0. What next? What next figure you can imagine? Where can you put the circle now? Do you have any idea? How about the circle touching, let's say, the x-axis, or let's say the y-axis, and the center lying on the other axis? So let me first draw the diagram for you. So here let us first draw our coordinate axis. And let us say our circle is this circle. Now here the center of the circle is lying on the x-axis and it is touching the y-axis. So this point easily we can figure out will be nothing but this distance, the distance of the center from the origin will be equal to the radius, and the y coordinate will be 0. So here is the origin, this is the center, which let's denote it by letter C. So this is the condition that we are having. So this is the special case when the center lies on x axis and the circle is touching y axis. So here h clearly is equal to r and k is equal to 0. R is the radius of the circle. So the standard equation that we have, x minus h whole square plus y minus k whole square equal to r square, becomes x square, instead of h we'll put r, so we have plus r square minus 2rx plus here k will become 0, so we have only one term from this expansion, and that is y square equal to r square. R square again gets cancelled, and what we have is x square plus y square minus 2rx equal to 0. I hope this gives you a fairly good idea as to how the equation of circles is changing depending on the location. So the easiest and the simplest form that we have come across is when the center is lying at the origin. So we now are going to look at the one last maybe possibility, which is when the circle is touching the x-axis and the center is lying on the y-axis. So here is our axis, x and y respectively, and the circle which we are talking about in this case is this one. Now similar to the previous case, the center will have the coordinates equal to 0, r, because the distance of this C from the origin, C is nothing but the center, will be again r, and the x coordinate of any point lying on y axis is 0. So here we have, let me give the title first, center lies on y axis and circle is touching x axis. So our equation becomes x minus, let me straight away write, because from this we have h equal to 0, k equal to r, again r is nothing but the radius, so x minus h becomes x minus 0 whole square plus y minus r whole square equal to r square. Now here we get x square plus y square minus 2ry equal to 0. So this is the case when the circle is touching the axis of x. So basically now you have a fairly good idea of how an equation of a circle will look like, and in what different cases how it will change depending on where the center of the circle is lying and what is the radius of the circle. So this is it for the first lecture. Let's meet again and take this forward and solve some nice good questions and see what is going on.